Hello students, welcome back to my YouTube channel Data Shah. In today's lecture, we'll be talking about mathematical expectation and variance. So what do you mean by mathematical expectation? Or we can say what is an expectation? So let me define, let x be a random variable. And phi of x be a function of capital X. Then the expectation of phi of x is denoted by E of phi of x, or we can also denote it by the mean or the average of the random variable. So it is also denoted by mu x, or we could say x bar. So these are some of the notations that you need to remember for expectation of a function. So we'll be considering both the variables, discrete and continuous. And we have already done what is a discrete random variable, what is a continuous random variable. So if you have not seen my videos, you can refer to the playlist and just have a look and you would understand what is a discrete and a continuous random variable. So what will happen? What would be the formula for the expectation when we are talking about discrete random variable or continuous random variable? So let us quickly see. So if x is a discrete random variable with finite values, so I'll take the values as x1, x2 up till xn, and the respective probabilities p1, p2 up till pn. So then the expectation, let me change the color of the pen. So the expectation of x would be x1 p1 plus x2 p2 plus x3 p3 and so on up till xn pn. So I can also rewrite this as summation I going from 1 to n xi's pi's, or I can also rewrite this as x p of x for the I values. So as I have just explained you that the expectation of x is also referred as x bar. So you can also see somewhere that this can also be written like this. So these are the different notations and the formula for a discrete random variable. Now, whenever we are talking about discrete random variables, so as I have explained you, what is the expectation of x, right? So when I'm talking about the expectation of some another function, then what would be the value? So let's see that. Expectation of phi of x would be summation phi of x into p of x. So as by the definition, this would be the formula for the expectation of phi of x. Now, phi of x could be anything. Now, if we put phi of x as x square, right? Because it is a function of x, so it could be anything. So I'm taking it as x square. Then, what would be e of x square? It is nothing but x square into p of x. So whatever you are getting the function, it could be x cube, it could be anything. Then you just need to write the phi of x multiplied by the respective probabilities. You just need to take the summation over I, right? And then you will get the final answer. Now, this is when we are talking about the discrete random variable. Now, what will happen when we are talking about the continuous random variable? So let me just take continuous random variable. So continuous random variable are those random variables in which we are talking about the range. That means the intervals, right? So here we are talking about the decimal values as well, not only the definite values, right? So we have decimal values, the whole values and everything in the entire interval range. So those are known as the continuous random variables. So what would be the answer if the formula, sorry. So if x is a continuous random variable, then the expectation of x is defined as where fx is the PDF, the probability density function, as we all know. So here you will notice what's the difference between the expectation of x in the continuous and the discrete. That in the continuous, we are talking about the integral and the limits are from minus infinity to infinity. Whereas when we are talking about the discrete, we are talking about the summation. So that's the basic difference in the expectation formula. Now, what would be the formula if we are talking about the E of phi of x? It would be same. And what would be the formula if I substitute it to x square, for example? If I put phi of x as x square, then E of x square is minus infinity to infinity x square fx dx. Everything remains the same. The only difference would be in the continuous random variable, you will have an integral sign and the limits would be from minus infinity to infinity. In the next video, I'll be talking about its questions as well. So next, we have the properties of the expectation. So let me just explain you about the properties of the these properties are very important when we'll be talking about the formulas. So the first property is that if x is a random variable and a is a constant, then So what is the expected value of AX? So we have it as A times E of X, right? And if we are talking about the expected value of only A, that means the constant. It is nothing but A only. Okay, so whenever we are talking about any constant and we need to find out its expected value, so it would be just the constant and nothing else. Now, in this, if we have, for example, E of X plus A, then this would be E of X plus E of A. So we are just left with E of X plus A. So this is our first property in which we are talking about a random variable and only a constant. So next we have the second property in which we are talking about two random variables. So they could be anything, they can be discrete or they can be continuous random variable. The properties remains the same. Then the expected value of X plus Y would be E of X plus E of Y. So this same property we have used in the last one that I have written. And similarly, when you want to find out the expected value of X minus Y, then that is E of X minus the expected value of Y. The next we have if we take for example phi of X as AX plus B, then let me just where A and B are constants. Okay. Then the expected value of phi of X would be the expected value of AX plus B. So that's nothing but the expected value of AX plus the expected value of B. So as we know that A and B both are constant, so we get here A times the expected value of X plus B. So this is what we get as the answer when we are talking about the expected value of phi of X. The last and the most important property that we'll be using quite often in our upcoming videos, that if X and Y are two independent variables, then E of xy would be equal to the expectation of X multiplied by the expected value of Y. So these are some of the important properties of the expectation, and we'll be using all of these or some of these in our upcoming videos. So do remember all of these properties. So in this next we'll be talking about the variance and the standard deviation. Again, the variance, how to calculate the variance of discrete and the continuous random variable, or we are talking about the standard deviation for a discrete or a continuous random variable. So let me just write down variance. So variance is the variance of a random variable is defined as the expected value of x minus x bar whole square. That is, we denote the variance as bar of x or sigma square. These are the different notations, and it is the expected value of x minus x bar whole square. So uh, we also have another, we can solve this. So let me just quickly solve this. As we know the properties of the expectation. So this is nothing but x square plus x bar square minus twice of x into x bar. So I have just applied the a minus b whole square formula. So a square plus b square minus 2ab. Now using the property of the expectation, that expectation of x plus y plus z would be e of x plus e of y plus e of z. So I'll just do the same. Now, e of x square would remain as it is. Now, what is x bar? X bar is the mean value, right? And if it is a mean value, we know that it will be a constant. So, x bar being a constant, it would be just x bar square, right? The expectation of a constant is constant only. So, I have just written the constant value, that is x bar square. Now here, when we are talking about this, 2 is again a constant, so it will come outside. X bar is also a constant mean value, so it will also come outside. So I'm only left with the expected value of x. Now, as I have explained you that x, expected value of x is also written as x bar. So I can rewrite this. And here I have used the property that a of x is a times e of x. So what we have got, this is x bar square minus twice of x bar square. So when you will solve this, this would be e of x square minus x bar square. So this can be written as e of x square. X bar is e of x whole square. So this is nothing but my variance. Variance of x. So if the expected value or the expectation of x square is given to you, you can directly calculate the variance of x. So the standard deviation, it is denoted by the standard deviation of x or sigma x. It is just the square root of the variance of x. Or I could say the square root of e of x square minus e of x whole square. Now, let us see what would be the value of the variance when we are talking about the discrete random variable or the continuous random variable. So, if x is a discrete random variable, then sigma square x would be the summation of so how do we get this? Because we know that this is nothing but the expected value of x minus x bar whole square. So x bar is also written as a mute sometimes. So using that, you will get this value. So summation xi minus mu whole square, uh, where mu is mean. Okay. Now, standard deviation would be just square root of this, right? So it's very easy as I have explained. Now, if x is a continuous random variable, then sigma square would be the integral from minus infinity to infinity, where your pi are the respective probabilities and fx is the respective PDF of the continuous random variable x. So this is how we can calculate the variance, and standard deviation is just the square root. So you just need to calculate the variance from this, and after that you can calculate the standard deviation easily by taking the square root. So in this lecture, we have discussed about the mathematical expectation, variance, and standard deviation. And in the upcoming lecture, we'll be talking about its various questions. So do like and share my videos and subscribe to my YouTube channel if you have not done yet. So hit the bell icon for the notifications for the new upcoming videos. So we'll meet in the next lecture.